Okay, here on example 2, we're going to be working with an angle of depression. Okay, so an angle that kind of goes downwards. It says that in Cottonwood, Idaho, there's a place called the Dog Bark Park Inn. It's a popular tourist attraction featuring a hotel in the shape of a 30-foot wood-carved beagle. Pedro looks out the window 30 feet from the ground and spots a fire hydrant at an estimated angle of depression of 40 degrees. What is the horizontal distance from Pedro to the hydrant to the nearest foot? Okay, so let's draw that out real quick. They're saying that he is up here in the window, 30 feet up off the ground. We want to know how far away he is um, in a horizontal distance. So when they say in a horizontal distance, they're not asking for the hypotenuse. They're asking for this length down here. We know this angle is 40. So what I can do is if I take this out and I drop that side down, there's sort of two different ways to approach this. So we know that this horizontal distance is x, so we could also put it as x up here. Now the way that they are going to do it is they're going to say that we are going to use the height of 30 and this angle together, these two pieces of information, in order to find this missing part up here using this triangle with an angle of depression. Okay, so that would be, this is the opposite side from the angle, and this is the adjacent side to the angle, right? We have the hypotenuse, we have the opposite and adjacent. So this is our opposite, this is our adjacent. So if we're doing opposite and adjacent, we want to use the sine property that includes those two. So recall that our options here come from that little phrase, SOHCAHTOA. Okay, so if we want opposite and adjacent, we're looking for the tangent. So we're going to say the tangent of 40 degrees equals opposite over adjacent. And let's fill in what we have from our picture right now. The opposite is 30. The adjacent is x. Okay, now the other way we could do it is that we could say, well, we know these two are making a right angle, okay, because this was 30 straight up. This was looking straight to the right. So this should be a 90-degree angle, which means that this part right here be like 50 degrees. Okay, so we could use that and that and that together. We could say that the opposite side and the adjacent side here, well, that would once again be a tangent, but it'd be a tangent where x is on top. So they would be like this. Tangent of 50 is x over 30. Right, because this is the opposite and this is the adjacent. So we could set it up either way. They're setting up with the first one, so I'll just erase this off and go ahead with what follows their example. Okay, so they get here, tangent of 40 degrees is 30 over x. Okay, then they say multiply each side by x. So that was kind of the step I was taking before. This is just, we're just sort of shooting for getting x by itself before we do anything else, before we simplify what that tangent value is. Okay, so x tangent of 40 is equal to 30. And dividing both sides by tangent of 40, we get that x, that thing that we're looking for, is going to be found by taking 30 and dividing it by the tangent of 40 degrees. Well, at this stage, we'll simply go to a calculator and type in tangent of 40 degrees. Right, this is the step where we're relying on previously discovered values made by measurements or made by, kind of calculations that are beyond what we're doing right now. But we go to a resource to find what that tangent value should be. So we get 0.84. Okay, so if I do 30 divided by that, I'm going to get an answer of 35.75. 35.75. And looking at the original picture, just want to make sure that kind of fits, 35.75. Yeah, so if this is 30, That would be another 30. So I guess my drawing wasn't drawn perfectly to scale, but we would expect that this length was going to be larger than the height. So 35 feet sounds good to me. And that is how we would go through and solve that problem.